Hello everyone. Today we are dealing with the new lesson Ray Optics Part 1. In this unit, basically we have to focus on the key points: reflection of light, laws of reflection, spherical mirror, refraction of a light and laws of refraction, principle of reversibility of light, refraction through a parallel slab, refraction through a compound slab, apparent depth of a liquid, total internal reflection, refraction at spherical surfaces, its introduction, assumption and sign conventions, refraction at convex and concave surfaces, lens maker formula, first and second principal focus, thin lens equation and linear magnification. First we have to see what is meant by refraction of light. Whenever a ray of light passes obliquely from one transparent medium to another, it deviates from its path. That is, refraction is the phenomenon of change in the path of light as it travels from one medium to another when the ray of light is incident obliquely. Or it can also be defined as the phenomena of change in speed of light from one medium to another. Here we have to study the refraction of light through a given pair of media. We consider here the pair of media having rarer medium and denser medium of refractive index mu. Rarer medium is optical medium having smaller value of refractive index, where the denser medium is optical medium having larger value of refractive index. Here, ray of light initially incident on the interface between rarer and denser medium and get refracted in the denser medium. And when the refracted ray again incident on the second interface between denser medium and rarer medium, it get emerge from the rarer medium. Let us draw the perpendicular to the two interface, which is known as a normal. I be the angle of incidence, that is the angle made by incident ray with normal, and R be the angle of refraction, the angle made by refracted ray with normal. For the first interface between rarer and denser medium, I be the angle of incidence and R be the angle of refraction. But when this refracted ray incident on the second interface between denser and rare medium, R will act as the angle of incidence and I will act as the angle of refraction. Now let us see the laws of refraction. The first law states that the incident ray, the normal to the refracting surface at the point of incidence, and the refracted ray all lie in the same plane. Where the second law, which is also known as Snell's law, states that for a given pair of media and for a light of given wavelength, the ratio of the sign of the angle of incidence to the sign of angle of refraction is always constant. And the constant of proportionality, which is known as refractive index, is defined as the ratio of sign of angle of incidence to the sign of angle of refraction. This constant, which is called as refractive index of the second medium with respect to first medium when the ray of light travels from medium 1 to medium 2. Similarly, we have the refractive index of medium 1 with respect to 2, which is given by sin r. This constant mu is called refractive index of the medium, where I is the angle of incidence and r be the angle of refraction. Here it is the nice representation of refraction of light through a glass surface. When the light incident on the denser interface of the glass and air medium, it refracted through a glass medium and the velocity of light changes. This is the another one example of refraction when the light incident on the glass jar, how it changes the path. When the light is moving from more dense medium to less dense medium, or when the light is transfer from denser medium to rarer medium, the refracted ray bend away from the normal, that is angle of refraction increases. In case when the light is travel from rarer medium to denser medium, the refracted ray bends towards the normal, that is angle of refraction decreases. Here it is, we can see this both the cases. In the first case, light is traveling from rarer medium to denser medium. That time the refracted ray bend towards the normal. And on the second interface, the light is traveling from denser medium to rarer medium. The refracted ray or emergent ray, it is bent away from the normal. So in the first case, the angle B is smaller than the angle C. The refractive index of optically rarer medium is lower and that of the denser medium is always higher. Refractive index of denser medium with respect to rarer medium is smaller than 1 and that of the rarer medium with respect to denser medium is less than 1. Refractive index of air is equal to refractive index of vacuum, which is equal to 1. In refraction, the velocity and wavelength of light change. In refraction, the frequency and phase of light do not change. Now, the refractive index of given media with respect to air is defined in terms of velocity of light, as it is the ratio of velocity of light in air medium to the velocity of light in given media. Or in terms of wavelength, the refractive index of medium with respect to air is defined as the ratio of wavelength of light in air medium to the wavelength of light in the given medium. Now let us focus on the principle of reversibility of light. Once again we consider here refraction phenomenon in the given pair of media. Here we can consider two mediums. One is rarer medium A and denser medium B of refractive index mu. In denser medium, we'll put one more refracting surface. Now let us see the ray of light when it incident on the first interface, it get refracted in the denser medium. But when the refracted ray incident on the refracting surface, it is again refracted in the rarer medium. Now we draw the normal to the interface between rarer and denser medium. Let I be the angle of incidence and R be the angle of refraction. Now for the given phenomena of refraction, when the light is traveling from rarer medium to denser medium, refractive index of medium B with respect to A is given by the ratio of sine of angle of incidence to the sine of angle of refraction. Similarly, when the refracted ray incident on the refracting surface placed in the medium B, that time light is refracted in the rare medium, that time the refractive index of medium A with respect to B is defined as the sine of angle of refraction to the sine of angle of incidence. If you multiply these two equations, we will get mu B into mu A is equal to 1, or refractive index of medium B with respect to A is always the reciprocal of refractive index of medium A with respect to B. If a ray of light, after suffering any number of reflections and or refractions, has its path reversed at any stage, it travels back to the source along the same path in the opposite direction. A natural consequence of the principle of reversibility is that the image and the object position can be interchanged. These positions are called conjugate positions.